these problems are a little bit harder and they're from your textbook. This is number 64 in your textbook. So again, if we have a story problem, the first thing you want to do, you want to read and find all the conversion factor. So vanillin has a threshold limit of 2 times 10 to the negative 11th gram per liter. That per tells you this is a conversion factor. So 2.0 times 10 to the negative 11th gram is equal to 1 liter of air. The current price of 50 grams of vanillin is $112. This is also a conversion factor. Continue to read. It says determine the cost. I know I'm going to look for dollar signs within the vanillin so that there could be detected in a large aircraft with a volume of 5 times 10 to the 7 feet cubed. My final units have to be in dollars. We know that if it's in dollars, we have to go to grams. And to go to grams, we need liters. Liter is a unit of volume. In general, unless you have a unit on top and a unit on bottom, you're going to start with the number that has only one unit. So this is going to be 5.0 times 10 to the 7 feet cubed. We know cubic feet is a volume unit. So that means we need to convert it to liters. So feet, we know we're going to go to meter. 1 meter is 3.28 feet. Since it's cubed, I need to cube. I need to cube the bottom and the top. The feet cubes cancel out. If we stop here, we're going to have units of meters cubed. So I need to continue on. I need to go from meters to centimeters because we also know that 1 centimeter cube is equal to 1 milliliter. This is a conversion that you have to memorize. So 1 meter, because meter is bigger, has 100 centimeters. Since the units are cubed, I need to cube the entire number and unit. The meters cubed cancel out. Do not want centimeters cubed, so I continue. Centimeters cubed, this is 1. This is 1 ml. The centimeters cubed cancel out. Here, I do not have to cube the entire thing because 1 centimeter cube is equal to 1 ml. I do not want milliliters because I have to go to liters to go to mass. So diagonals, ml, ml, liters. Liters is the bigger prefix, so this gets 1,000. The milliliters cancel out. Liters, diagonal. The number in front of liter is 1. So now I could use this conversion factor. 1 liter has 2.0 times 10 to the negative 11th gram. But I don't want grams. I want dollars. So I need to continue on. This is grams. This is grams. The number in front of grams is 50, and that is equal to $1 or $112. Since these numbers are cubed, this is going to be 1 meter times 1 meter times 1 meter. On the bottom, it's going to be 3.28 feet times 3.28 feet times 3.28 feet. Here, it's going to be 100 centimeters times 100 centimeters times 100 centimeters. On the bottom, it's 1 meter times 1 meter times 1 meter. Because the cube is on the outside of the parentheses, so you must cube the unit as well as the number. Here, the unit is already cubed, so we do not cube the number. And then you multiply and then divide and get 0.06348. Now we do sig figs. Conversion factor, conversion factor, conversion factor, conversion factor, conversion factor, conversion factor. We look at the initial number. There's 2 sig figs because in scientific notation, only the first part count and all of it. So I start from the left. I go to the first non-zero digit, which is 6. 1, 2. I look 1 to the right. Less than 5, so the 3 stays. We must keep the 0 as placeholder and the units are dollar signs. This one is another problem from your textbook. Since it's a story problem, go through and identify all the conversion factors. So 1 parts per million is the same thing as 1 gram of chlorine per million grams of water. This is a conversion factor. So we have 1 gram chlorine is equal to 10 to the 6 grams of water. Calculate the volume in milliliters. So we need to find milliliters. So we're looking for a volume that needs to be added to a pool of solution that contains 6% of chlorine by mass. When you have something that is 6% chlorine by mass, it means if I have a whole pie, 6% of that is chlorine and the rest of it is something else. So in this case, since the chlorine is mixed with water, 6% is chlorine. The total is 100%, which is the chlorine plus the water. Since it's a percent over percent, we could use any type of unit, which is, I could use 6 grams of chlorine. I could use 6 milliliters of chlorine. And on the bottom, it's going to be 100 because it's part to total. And here, since it's chlorine plus water, it is a solution by mass. And there are 2.0 times 10 to the 4th gallons of water in the pool. So again, you want to start with the unit by itself. So I'm going to start with 2.0 times 10 to the 4th gallons of water. We know I need to go to liters, so I'm going to convert my gallon into liters using this conversion that was provided. Gallons water, 1 gallon water, 3.79 liters of water. And if you notice, I put water in because we are dealing with water, we're dealing with solution, and we're also dealing with chlorine. Remember, a solution is a mixture of the water and the chlorine. I do not want the liter of water. I want the milliliter of what needs to be added to the pool of solution. So I need to get rid of liters of water. To get rid of liters of water, I'm going to use the density of water, because the density of water is given as 1 gram water is equal to 1 ml water. This tells you this is a conversion factor. To go to milliliters of water, I need to convert my liter into milliliter. Bigger prefix is the liter, that gets to 1. This is 1,000. The liters cancel out. Milliliters of water, milliliters of water. There's 1. This is 1 gram of H2O. I don't want grams of water, I want milliliters of solution. So if you notice here, right here, we have grams of water, and we could go to grams of chlorine. So diagonal units is gram of water, gram of water. This is 10 to the 6th to 1 gram of chlorine. The grams cancel out. I do not want chlorine, I want the solution. So I come here, where is the gram of chlorine, to solution. It's a gram of chlorine, there's 6 grams. This is 100 grams of solution. The grams cancel out. But now we are at grams of solution, and we want milliliters of solution. We know the density of solution because it's also given as 1 gram of solution per 1 ml. So that also tells you that 1 gram solution is equal to 1 ml of solution, and it's a conversion factor. So this is 1 gram solution to 1 ml of solution. So all the units cancel out, and I have milliliters of solution. If I do my math, I get something like this. Now I need to go back and do sig figs. Conversion factor, all of these are conversion factors, so we don't use it. So I look at the first number. This is in scientific notation, so only the first part counts, so there's 2. My final answer has 2. 1, 2, I look 1 to the right. Since it's greater than 5, the 2 becomes a 3. Since this is in the hundredths place, I need 0 as placeholders, ml as units.